Hello, this is Charlene. We are going to complete the square of our quadratic, We're going to convert it to the vertex form, and then we're going to be able to identify what the vertex is of our quadratic. Okay, so let's get started. The first thing I'm going to do is divide out the leading coefficient of 3. However, I need to warn you that later we are going to multiply that leading coefficient back in. So right now we're going to divide it out just to make our work easier, but later we will put it back in. Okay, so when I do that, this becomes x squared minus 2x. Okay, let's fix that a little bit here. X squared minus 2x minus 15. Okay, so when we complete a square, we are assuming that this negative 15, this third number, is just not working for us. So we're going to move it to the other side. Well, we'll just use order of operations to move it to the other side. We'll add 15 to both sides. So I'm going to end up with x squared minus 2x. I'm going to leave a space here. I'm going to leave a space here because we are going to use what I call my magic bullet. This magic bullet for completing the square is going to go in this space. So let's go ahead and write that in. It's going to be plus the magic bullet, plus b over 2, and that ratio will be squared. And like I said, we are adding the 15 to both sides. Adding 15 to both sides. So that means that I'm going to end up with 15 over here. But if I add the magic bullet to one side, I also have to add the magic bullet to the other side. But we need to recognize that we are talking about a quadratic, and our quadratic is an ax squared format plus bx plus c, whatever that number is c. So we need to recognize that our b value here in our magic bullet is coming from this b value right here, the negative 2. So we're going to go ahead and plug that in and put it as negative 2 over the 2, and that ratio will be squared, and that is my magic bullet, b over 2 squared. Okay, so I'm just going to keep using order of operations to keep working it down. So I've got x squared minus the 2x. Now I'm going to go ahead and calculate my magic bullet. My magic bullet is negative 2 over 2, which is negative 1. Negative 1 squared is a positive 1, so it's going to be plus 1. And then that's still equal to my 15 plus my 1, which makes it 16. So at that point, I have now completed the square. I have completed the square. That is accomplished at that level. That's what I've done at that level. Okay, so when I've completed the square, it actually turns my quadratic into a perfect square trinomial. And what that means is that this little piece of my equation is the perfect square trinomial, and I can now factor it according to an easy pattern. So the square root of x squared is an x, and the square root of the 1 is a 1, and the sign in the middle is a negative. So right there, this piece right here, this is the factorization of my perfect square trinomial. And I still have my 16 over here is equal to 16. So this is almost the vertex form, but we're going to, again, I've reminded you that we're going to put this 3, we divided it out at the beginning, but we're going to be multiplying it back in to our vertex form here at the end. So we're going to don't forget to multiply the leading coefficient back in. So what I'm going to do, I'm going to rewrite it. I'm going to rewrite it as f of x, just because this is a much more perfect version of the vertex form. So the f of x is equal to, and I'm going to multiply the 3 back in to everything. I'm also going to do one other thing. I'm going to move the 16 back over here. So this is actually going to look like this. It's going to look like x minus 1 squared minus the 16, and I'm going to close that bracket. But at that level, that's what we need to understand, that we have just taken that 3 that we divided out, we're now going to multiply it back into it. So we're going to complete this using order of operations. So f of x is equal to 3 times x minus 1 squared, and 3 times the 16 is a negative 48. So that right there, that is my perfect vertex form. That is my perfect vertex form. So I'm going to acknowledge that as such. And what that means is that we have now turned our original, this is my original quadratic, and this is its perfect vertex form. This equation is the same as my original equation. Okay, so from that, I can now derive my vertex. The vertex of my original quadratic is going to be equal to this number and this number. So it is going to be equal to a positive 1. The x is always the opposite sign. It says negative 1. We're going to do a positive 1. The y value is going to be the same sign, so it's a negative 48. So the vertex of my quadratic is equal to, close that parentheses there. There we go. So the vertex of my quadratic is equal to 1, negative 48. That is my vertex. Okay, so again, just to review what we did, we actually completed the square. This is the completion of the square right there. And then we have converted it into the vertex form. This is the vertex form. And we were able to find the vertex. This is the vertex. Okay, hopefully that helps you go through the process and helps you remember all the steps in this process. Click on the subscribe button, click on the like button, and we'll see you back soon.